Matthias, hi.
Hi, how are you?
Fine. Glass Competence Center. What a nice laboratory. We already know each other, but what are you doing? Who are you?
So I'm Emanuel. I'm a student researcher under Matthias, and I'm also doing some research on glass and improving, hopefully, the glass and shaping the future of the glass industry.
That's what I'm interested in. I'm looking for innovations, actually, and I see something I've never seen before. So tell me everything about, if you are allowed to, let's say. Fine?
Yeah, it's fine. But I will start a little bit with the general idea. In general, glass is flat. We know the flat glass process, the flat blood process as an industry process. It's very clear, transparency. This is pretty cool, but we had a big mistake in it. Yeah, it's weak. It's really weak.
This is not glass, this is a sort of plexiglass, but of course it represents a weak piece of glass. Yeah.
It's really a weak piece, and we had a large deflection, and this deflection is in the most cases the limit state for us, and so we have to, what we can do, we can improve this by two different approaches. One approach is additive manufacturing, so that we bring on the top of this plate a structure, a grid structure, and the other approach is we fold the glass. But I will say, Emanuel, please tell something about AM glass printing. What's the idea behind?
Yes, so let me show you our approach on a basic example.
Oh, so by adding these structures on top, you create a higher piece of glass. Well, usually the easiest is to just make the glass thicker.
Yeah, okay.
And then over the entire area, you are partially increasing the height.
Yeah, at the places where it's needed. Only there.
Only there.
So it's mainly following the main directions, the main direction of the plate. And so we're creating stiffer structures.
It looks also cool. Can I also have it in different colors?
Yes, of course. So we produced, together with Maple Glass Printing, some pieces to show that it's possible. And
This is also glass, or this is plastic, no? This is from a 3D printer?
yes, that's plastic.
But this is also 3D printed glass.
Yes, that's soda lime silicate glass, like the glass in front of us or behind us.
Oh, so then it bonds perfectly also to the regular float glass.
Yes, that's our goal. So also this structure we have in a small scale already here.
And they perform similarly when you have this grid or this pattern. Is there? I'm already thinking about architects being creative with. Can you also play a little bit around
Yeah,
with
you
that?
can play a lot. So there you have to look at some basic principles, but mainly we have a huge variety of different geometries you can print onto these glass plates.
And I also see you can also do different colors.
Colors, also patterns, or also like practical approaches on it.
I can also put it together like a insulated glass unit, so you have still easy to clean on the outside, and inside you have the structural increasement or enhancement. That's a cool idea.
Also, so we can save a lot of material, so up to the range of maximum 80% more or less.
Okay, that's a lot. So ideal circumstances, whatsoever, about 80%, so up to, that's really a lot. Oh, wow.
And so we can save material and also the weight of the whole facade system.
Yeah, of course. Actually now with triple glazing and whatsoever, it becomes more and more heavy. Oh, I also see something over there. Can you talk about that too?
Yeah. This is the other approach, so that we take the flat glass and fold it with a special heat technique.
Yeah.
In general, you know the normal mold techniques for glass, so that you had some curved structures, but you can do this only the one mold, only for one piece.
Precisely.
Yeah, and this is not so cool and not so efficient. And here with this technique, we can don't need any mold. We do this together with the Fraunhofer Institute in Freiburg.
So it's a new technique in order to make that happen.
Yeah, to make that happen.
Okay.
And so we create also with the same type of glass higher stiffness. It depends on the height of the whole construction, but we are in the same area, so we can save more or less 80% in maximum from the stiffness. And so we can create large span widths with less glass. This is the idea behind.
Show me. That looks also awesome. So by increasing the height of the glass, by folding it into a different geometry, you create this stiffness.
Here is the same glass, and you see, please be aware a little bit, but
Yeah, of course, yeah. You can already see that it flexes. Oh, incredible.
also the idea behind this here with the paper is the same. Here's a folded one, and this is a normal paper, and you see the big
Yeah.
difference, the really big difference.
Yeah, so one becomes a profile.
Yeah.
The height is what actually counts, and the other is just a material that is more bendable.
Yeah.
Oh, that's incredible. Same. So you mentioned the same savings.
Yeah, it's the same range.
Yeah. Oh, that's interesting. When do we get this in the market?
We had to scale it up, also because this is not useful for the facades at the moment. We have to scale it up,
Yeah.
and then we will see it. It depends a little bit on the laws and so on. You know the stuff in Germany.
Yeah, of course, of course.
But it doesn't matter. I think it can take in 5 years. I think we hope we see that with this technique.
But we are sitting here in the laboratory, so you have all the testing equipment over here and also on the entire campus. So you make sure whenever it's out in the market, it's safe, and you can also, you know exactly how it performs and what's within the rules and guidelines and whatsoever.
We do we do on the one side the design for it, what makes sense from the structural optimization, and then we prove it. Here's one sample of it to see where the weak points from the calculation to do a validation also with the test setup to see where the weak points to say to be are safe.
No, of course, I can't wait to see it because it also looks beautiful with the reflections and so. So thank you very much. For sure, innovation, we will try to look forward to get in our buildings. Thanks.
You're welcome. Thanks that you are here.
It's a pleasure.